In this video, I'll discuss getting the basic statistics parameters out of R. For the mean, the standard deviation, and the 5-number summary, those commands are intuitively obvious: mean, standard deviation, summary. Okay. The way you do this is you have your data already entered in some sort of data frame. Either you entered it yourself by hand or you attached a data set. In this example, I've attached the data set chick weight, giving all those chickens versus the diets, into the computer already. If I want the mean of one of those variables, say the weight, or that's the only thing that makes sense to get the mean out of there, I type mean, then in parentheses I put the variable. I've done it formally here where I put chick weight, $weight, but if this is the only database that's attached and this is the only weight with the lowercase w that you have around, if you just type weight, you'll get the same effect. So that would just give you the mean of those 578 weights for those chickens. If you want the standard deviation, of course this assumes it's normally distributed, otherwise it doesn't make a lot of sense. If you want standard deviation here, you just do the same thing. SD is abbreviation for standard deviation. And if you want the 5-number summary, just type the word summary. What do you get out for this? You'll get the min of the data set and the max. You get the mean, which you already knew from up there, but that's okay. You get the quartiles. First, the second, which is the median, of course, of the entire data set, and the third. So here's what it looks like in R. Let's say I attach that Motor Trend car data again, and I want to make sure I have the variables right, so I'm going to go type, spell it right, and you can see all the data that it has stored here. Some of the headings don't make a lot of sense, like carburetors wouldn't matter, but I've got miles per gallon, displacement, horsepower, and weight. Okay, I can look at any of those and kind of see how those are written, because that's going to make a difference. So let's look at miles per gallon. So I just type mean, and because that's the only miles per gallon around, I can just go MPG, and it gives me the mean. I want the standard deviation, do the same thing. And if I want that 5-number summary, I just go summary of MPG. And there we go. You can do the same thing for weights, which I think was WT, yep, and standard deviation for weight. Now if you remember what I've kind of said all along here, by doing it this way, the mean is totally lost. I can never use the mean in another calculation. It just printed it out, and that's it. If I want to take that mean and maybe use it in a different calculation, I better give it a name. Now most computer programming, using the name to be the same as a command is a very dangerous thing to do. Here in R you can get away with it, but we're not going to do that. Let's call it mu. Alright, and we go mean of weight. Now that variable isn't printed out exactly, or directly, but it is stored, and if I go mu, I'll see it. Something else that's done frequently is to change values into z-scores, into z-values. And that can be done one at a time, and I want to show you this because I want to show you that you can do arithmetic right in R. So here's the formula for z. So if I have some value x and I want to change it to a z-value, then I take x, subtract the mean from it, and divide by the standard deviation. Now let's see how that's done in R. Okay, you have to enter the values. So here I've entered the value for x, which is 32. I need the mean, which is 22.5. I need the standard deviation sigma, which is 3. Then I can just type this out just as though I'm typing a regular arithmetic equation. Parentheses x minus mu in parentheses divided by sigma. And I call that z, and I get the z value out. If I can see it when I print it, if I want to print it. Also, I don't have to do it this way. That's just a nice way to do it because all my values are there. I can check what I did. The other way to do this would have been to write just the numbers. Z equals 23 minus 22.5 divided by 3. I would rather you do it this way. That's a formal way to do it, but it's much better. And if you ever end up programming in R where you saved your work and you're coming back to look at it, it is much better to write these out with names attached to them. So I'd prefer you do it this way, but this way also works. Just wanted to let you know that. If you have many data values, changing them one at a time is not a good idea, and there's two ways to do it. Here's one way, and that's to use the scale command. So when you use scale command, it takes all of the values here. I'm not sure how many were here. I can't remember. But it takes them and turns them into z-scores. Oh, there were 32 of them. That's right. It turns them into z-scores automatically. Right. You can also do it in the calculation, but this works out well. And it also, what it does is it will give you a listing. The first up to the last two, however many you have, will be the z-scores. And then after that, it will write the mean and the standard deviation. The function scale had to compute the mean and standard deviation, right, in order to change it into a z-value. So it computed these and it stores it at the end of that list, and sometimes that's handy. So let's do those commands in R. I'm going to attach a data set. I'll attach the chick weights. Okay, that's attached. And I'm going to type it out because it's a good practice. Who knows? It might have changed since the last time I looked at it. Probably not. Oops, where is it? Okay, weight is right here with a lowercase w on it. And let's say I want to take all of those values and I want to turn them into z-scores. So I can just go z, and I can use the term command scale, and after that I have to give it, which I'm doing formally to try to impress that on you, and I'll write weight. Okay, that's done. Now look at there's 578 of these. So when I type z, I get a bunch of z-scores, which if you've studied your statistics, you know what they mean. Now let's see, I've lost that whole list here. Okay. There's quite a few of them, right? Okay. Okay, so it gave the 578 entries were turned into z-scores, and then there's two more listed that will be listed at the bottom of here, scaled center, which is another word for mean, and then this is going to be standard deviation. We will check that. So I'm going to type in mean for the chick weights, and now I'm going to be lazy and just type in weight, and I expect to see 121.8183. Okay, now I'm going to go SD for standard deviation if I want to check that, and I get the 71.07196 out. Right. And the other way is to do it arithmetically, one at a time or a vector at a time.